So this series, I believe, is supposed to be aimed at people who are embarking on a retrofit project rather than specific details for professionals. So from that point of view, I'm concentrating mainly on the project process and how we manage risk and how we derive costs and how we deliver. So this is a standard project process. We always have an appointment and contract, essential. We always carry out a survey, absolutely essential. This is a digital measurement survey. We establish a brief. We establish a cost plan and the project risk strategy. We establish a program. Then we dive into design and PHPP. And if anybody doesn't know, the PHPP is a giant Excel spreadsheet developed by the Passivhaus Institute, which, as far as I can see, is ultimately the best energy modeling tool out there. So once we've got all that done, we go to planning and statutory consents, detailed design, procurement of contractors, components, materials, and then construction management, which also relates to risk strategy. We deliver this project through construction management, not through a main contractor, and I'll explain that as we go along. So what is the project process and what is the key to a successful outcome? Well, for me, the three C's are like a three-legged stool: clarity, communication, cash flow. Clarity, you need everything explained very clearly. You need to communicate very clearly, and if cash doesn't flow, the project just stops. Risk management, we need to understand the risks, we need to assign the risks, and we need to manage the risks. Now, mostly in a little project that we're talking about now, as retrofit upgrade, the risks and are mainly associated with how you deliver the project. Now, traditionally, the traditional route would be for an architect like me to do a design, get planning permission, produce tender documentation, get 3 or 4 contractors to bid, and then sign a contract. The problem with that is that when you choose a main contractor, you are assigning the risk to him, and he will price that risk. The other chart shows like the 4 cornered stools of project management: your process, your program, your agreement, and your resources. So where are we? We're in London, Southfields. This is the Southfields tube station right here, and the house is situated in a funny little plot of land left over, and all the houses surrounding it are 1930s design and built, and this is now a conservation area. So we had to get conservation area consent as well as planning consent. So starting with the survey, you can see the strange panhandle plan of the plot, the strange design of a semi-detached bungalow split down the middle, and then the survey of the actual building. And you can see just with your naked eye that things are rather squiff, and they were. And when developing a design, I usually ignore the squiffness and just keep all the lines straight for ease of replication. The next stage is the client brief. Very important to establish exactly what you want to do with the client. So the client saw what the neighbors did, which they filled in the little space between the 2 wings and created another bedroom. I mean, the plan, if we go back to the plan, very strange plan with this sort of higgledy-piggledy passage running through the house. So the next door neighbors did that, and the initial client brief was, let's try and squeeze in 2 more bedrooms and then like a row of wet rooms and services on the back. The problem with that is this little red blob here is an immovable object, because that's where the main vent stack, the soil vent pipe was, and all the electrical incomings were in a cupboard there, and all the current drainage connected under the slab to that. And when we looked at rationalizing the plan without demolishing any walls to see if we could squeeze it in, it was obviously not possible. And so we dismissed that. The client also produced this wonderful detailed kitchen plan, which is great, and I encourage clients to set down what they want. It helps the architect. So the first proposal was this, keeping within the existing structure and keeping the existing bathroom, expanding the existing little WC to make a shower room and WC, keeping the existing bedroom as a study, having the laundry and other services and the MVHR and hot water and all the services in this corridor, keeping the kitchen as a separate unit, having the dining living together, and then having a separate room here, which could be used as an extra bedroom or a study. In all cases, this project, we have 4 workstations. So the final proposal looks something like this, which is what we built. This wall here literally fell down while we were demolishing, so we had to rebuild it properly with stud work. But effectively, we kept the existing bathroom, improved the WC in the shower room, and we had this service cupboard scenario down the passage there. The kitchen dining room was open plan, and we had this folding sliding door between the dining room and the living room. One of the key things we decided to do was we were going to replace the flat roof, and in order to accommodate services, we actually lifted the whole thing by 50 millimeters. And you'll see that later on when I go through the detailed construction process. So we end up with a finished plan, some nice elevations and sections for planning, and the roof plan showing all the solar panels we were going to put on. Then we got into a very long discussion about the pricing, how we were going to work out what this project would cost. So this big spreadsheet was developed by myself and the client, and then given to our favorite builders work contractor to work out a price for labor and tools. So at this point, construction management kicks in, because by buying his own risk, the client is able to not pay extra, because he's paying for labor and tools from a contractor, and he's paying for materials, which I buy on his behalf as a construction manager. And the VAT on the materials is my construction management fee. So the client isn't paying any extra for that either. But ultimately, so around £100,000 for all the labor to finish the project. So once we'd added in all the fees, materials, systems, and the main contractor cost, and added a contingency, the planned outturn cost was £287,000. The actual, well, let's wait a bit. I'll show you that at the end. For every project, I do a program. It's absolutely essential. It's the roadmap of where we're going, how things are connected, and how long things take. And why I'm putting this up here is to show you that, in fact, the design process is sometimes longer than the construction process. And on this project, I'd allowed roughly 6 months for design and 6 months for construction. When we got to construction, by the time we organized and planned everything and got everything tendered properly and got all the materials planned, the construction program ended up looking something like this, which is detailed sort of week by week program showing all the various works by the various contractors, subcontractors, and specialists. And the challenging thing about this project was that the client was in situ for most of the time, for half of the project. We decanted the whole family into the living section and kept the bathroom operational. and then took everything out of the bedroom wings and replaced the central roof. And then at this point in the program, the family moved out for 6 weeks while we finished the living wing. Then we dived into the PHPP. Now, this is the EnerPHit verification page for the component compliance. It is slightly juggled because there is one component which is failing, which we are addressing. But the interesting thing about this is the heating demand and heat load are being measured by the client, and over a year's use, the figures here of a heat load of 13 watts per square meter are almost identical to his actual measured use. So when doing the PHPP, we take the plans and we delve into a whole other level of information: the treated floor area, the volumes, how many rafters there are in the way of insulation, the thermal bridges, the distance to the horizon and the height of the horizon from all the windows. So this is my way of doing it. Some people use spreadsheets. I prefer to use the information from the CAD program. And this is what you end up having to do with that information, is produce a diagram like this to verify for the Passivhaus Institute that you've actually worked everything out properly. So it's a great big section through the area surrounding the house and showing all the distance to trees, the height of trees, distance to the horizon, and the height of the horizon. And then the elevations show the thermal envelopes, the area of the thermal envelopes, and the airtightness strategy. So in the airtightness strategy, it's really quite simple. You must be able to follow a line through any section, and that line must be continuous for the internal airtight layer, and the line must also be continuous for the external dimensions of the envelope. The trickiest bit to achieve airtightness on was this bit over here, where we had to squeeze something up between the concrete column, this huge concrete ring beam which ran all the way around the house, and connected to this flat roof section, which I'll explain later. Right. So when you're embarking on an EnerPHit project, especially one with an existing slab, I would highly recommend that you are very unlikely to achieve EnerPHit verification using the energy demand method. So I've massaged the PHPP on the right-hand side to show what would be required. So you need to get a heating demand of 20 to fulfill that. And with the EnerPHit verification for the component method, you don't need to do that. But the component method has all these boxes ticked. And the energy method, you don't have to tick any of those boxes. However, the problem with that is that you have to uprate the insulation and the thicknesses so dramatically that you end up causing all sorts of problems with height limits and all sorts of problems with costs. I mean, for example, the floor assembly, this is what we actually did: 100 millimeters of PIR at 0.2. To achieve the energy method, we had to upgrade in 3 places: the floor, the new roof, and I'll over the page tell you about it. So this new roof would have to have another 50 millimeter layer of insulation on top of that. And the kicker was the external wall insulation. Under the component method, we achieved a U value of 0.175. In order to comply with the energy method, we needed to get down to 0.101. And to do that, we had to uprate the thickness to 180 millimeters and the lambda to a insulation that had a 0.022 rather than the 0.038. And the cost difference here, you can see that material cost 3,000 The material for the extra thickness cost 9,000, so that's £6,000 extra, which frankly we didn't want to spend. So we get into the details, and this really shows what the limiting factor was. The limiting factor was the height between the existing slab and the underside of the concrete ring beam to enable the front door to actually be put in place. And if when you have a chance, if you look at that detail carefully, you'll see that the edge of the frame is literally on the edge of the beam, because the strategy with the windows and doors was to move them outside the existing structure into a new insulated zone, so that they are completely connected insulation wise. By doing that, we also used structural insulation under the door frame and implemented that thermal bridge over there. This drawing also shows the principle that we adopted by raising the whole roof by 50 millimeters and then just scooping out some scallops on the original furring to allow the MVHR vents to pass through under this layer here is the airtight layer, which has got no penetrations. The OSB was fixed to the structure, and that had a layer of Alutrix on it, which is a super watertight and airtight barrier. And the underside of that forms the airtight layer. These two layers of insulation were put in place by glue, so we have no fixings through here. This whole sandwich over here is a glued sandwich with a top layer on OSB of standard felt roofing. So quite simple. The MVHR section tucks under the existing structure, and this forms the sort of spine of the services. Thermal bridges, right. So this is probably one of the most important thing that you have to attend to when doing a PHPP. The PHI is obsessed by thermal bridges, and when you actually account for all your thermal bridges, you can see why. They do have an effect on the energy model, a dramatic effect, but you have to approve where you get your information from. So you either have to go to something like Woofy Pro, which produces these wonderful colored diagrams to show you the heat transfer, and in the corner there it shows you the psi value, which is the value that you have to apply to the thermal bridge. So 0.04 psi value used for the windows. Over here, for example, we had a minus 0.02 psi value. And that affects quite a lot. But these drawings I do purposely to show exactly how the building is structured and built, and also to give the contractor clear instructions about what to do. So when we started, I mean, the first thing we did was took all the roof tiles off, took off the old tar paper, and replaced the tar paper with Tyvek and new battens, and reused the old existing tiles. This shows the the inclusion of mattresses for light fittings, things like that. So, and then the plasterboard was put on in two layers in this instance, and all the seams were taped. This is like showing the airtight construction and the perimeter ventilation. I'm going to motor on a bit because we are going quite slow. So the central roof, this shows the Alutrix on the OSB and the layers of insulation being built up. And then the final roof with the air source heat pump and the solar panels. We kept penetrations to a minimum. There are 1, 2, 3, 4 penetrations in the roof, which are all sealed. Right, getting onto windows and doors, I always do this as well. I do a 1:2 scale drawing at A1 and stick that on the wall to give the contractor no chance of escaping because these details are no prisoners. The other way of managing risk is to show clearly what you want from whom. So this is the window and door frame schedule because all the windows were built in plywood subframes because all the windows were the original windows were out of square and the sizes varied. So this is the sequence of putting in those subframes, making them airtight. And likewise for the main entrance door. And these are the doors installation. This beam here was 50 millimeters out of level. Here you can see the structural insulation of the main front door and the floor insulation. And at the end, I'll show you more. So this is the MVHR, and over here you can see how we resolved the thermal bridge at this point. But this is the blown insulation tucking underneath the new OSB, and then the other insulation just overlapping. But this worked out pretty well, this service wall, and you'll see a picture of that at the end. So for the MVHR, specialist consultants will produce a plan and a layout. This is the mechanical drawing, which also shows all the heating and lengths of pipes, which all goes into the PHPP. And then this is how we ducked and dived to get the MVHR to thread through the various bits of structure that were in the way. And over here, you can see how we had to go under, duck and dive under the concrete ring beams. And of course, you need an electrical plan. Again, managing risk. This is a typical electrical plan layout that I do where every fitting is dimensioned and set out. There's a key for everything, and the rules of engagement are on the drawing as well. So this is the MVHR installation, which went pretty smoothly. I kept on trying to tell the client to allow more room for the hot water tank, and the poor contractor had a bit of a time, but the client wanted to squeeze it in to create this little alcove here. And this ended up really quite nice. The floor insulation is pretty obvious. The airtight layer was, we put an additional airtight layer of a DPM across the whole slab because it was quite cracked. The external wall insulation is probably the messiest job on site. And the reason for this, this red arrow, if you have a chance, you can see this is dot and dab, which we forbade. And we spoke to the contractor and told him we wanted full coverage in order to avoid thermal bypass risk. So that we didn't catch the first row, but we caught the rest. And from then on, the contractor was very careful about buttering the full back of the insulation panels. This is just the process of installation, pretty standard. And then we get the final before and afters. So that's before, number one's before, number two's after. Then we get different views of the main elevation. Number 5 is the back before. Number 6 is after. Number 7 is the front before. And number 8 is the front after, including brick slips, which were introduced late in the day, as you can see in picture 9 as well, because the neighbor kind of insisted on, and they were a bit worried about the house being too white. One of the best decisions we made is carrying on the render on the soffits of the underside of the eaves and other things. Now, cost plan. So we planned 287,000. We delivered for 295,500, which is actually not bad and is just over £2,000 a square meter. So this is the link to tomorrow's webinar, which is about a product called Aero Barrier, which is actually quite amazing. If you're having a retrofit with tricky cracks and crevices, this will solve your problem. So Are there any questions, Molly?
Thank you. Yeah, thank you, Colin. Unfortunately, the settings in the webinar haven't allowed chat to be enabled, and it's not something that I can enable after the event. So hopefully, though, the Q&A in the end actually does work. So if people have got questions, it would be good if they could pop them in the Q&A. So apologies, I didn't want to disturb you while you were talking, and I
No,
couldn't
that's
type
fine. I'm going to stop
anything. So,
sharing and open the Q&A and see if there are any questions there. Nope.
so there aren't any yet, but hopefully they will start.
Okay,
Yeah,
we've got time. I mean, I
you've got
did
plenty of time. Yes, thank you.
I did go pretty fast. I mean, while you're thinking about it, I'm going to and while you're thinking about your questions, I'm going to show you some bonus content. This is what I'm working on at the moment, which is a new passive house in Wimbledon. The um, very difficult site, zigzag, but 140 square meters, insulated ground slab. We use the Eco Cocon walls, which is an amazing system. And the cost plan for this house is 500,000 or 3,571 pounds a square meter.
You're
And this
It's
is
not
the views.
sharing yet, Colin. I don't know if you know the slides are your bonus slides are not showing up just yet.
Okay, sorry, bear with. Oh, I'm in the wrong app. That's why. Zoom, share.
Excellent, thank you.
Okay, so here we are. That's the entrance view and the east view. Fitting this into a very awkward site, the west view and a section. And these are the details for the Eco Cocon system, which I can highly recommend, which I'd really like to use one day. And you can look at these details at your leisure. And this is what Woofy Pro does. So the psi value at the corner of this construction is 0.918, which is pretty damn near perfect.
Excellent, thank you for sharing that additional content. There are some questions that are popping in to the Q&A here, but I'm wondering whether David wants to
Yes,
uh,
I said to
contribute.
David, yes, please.
So I might just need to change some of the settings. So let's just. So David, you should be able to talk now.
Hello. Just how is that?
To everybody there, David is the client.
Yeah. Hey.
The best client I've had for a long time.
Oh, thank you. And I'm just on mic. I'm not on video. Okay, cool. Anyway, so I guess my comment would be I can comment on what the as-built performance is like and what the experience was like as a client, if people would like that. I'm an engineer, an academic at Imperial College, so um I got quite involved in the heating design and the interaction of the heating engineer, which was reasonably good fun. As Colin says, uh, I tend to be of the view that plumbers take all the space they possibly can to have fun with pipe work, and that you can go smaller than that. But then I also work on submarines, so my view of what compact pipe work is like is perhaps aggressive. Um, and but it's not a very big building, and because we were originally going to do an extension of it and have a plant room, but having sort of the circulation space of the plant room be the corridor then doubles up and saves you space, right? So So then you're pushing everything into as small a space as possible. You've got an MVHR that's a sort of in ceiling MVHR effectively, and then you're trying to fit everything in, and that was quite an exciting bit of 3D visualization to do. Basically, was how to get all the MVHR pipework fitting in a retrofit. Um, and The other side was that it was done over a school summer holiday. So we sort of started in May and then moved out for the summer effectively to some, because we had various friends who were on school holiday. So we migrated around various friends' houses for the summer, and then we're back in it, but not quite finished at sort of early September. So it's exciting from the point of view of phasing. Um, and that was quite dynamic and required, quite a lot of flexibility on everybody's part. And the builders were great actually for that. My other comment would be the airtightness. The airtightness, you go into Passive House thinking airtightness is going to be the big risk, is going to be the big thing. And the main contractors were not experienced in doing passive houses, so they were experienced in doing retrofit and insulation stuff, but they weren't experienced in airtightness. And actually, they were good as gold. And the crazy paint stuff really does work. And that was the dog that didn't bark in the project. The thing that's most difficult in retrofit, I think, is assessing the thermal bridges. That's the sort of the learning experiences. You really need to have to have access to somebody who can do Wi-Fi Pro calculations for you. And if I'd have gone and learned that, or one of us had gone and learned that at the beginning, that would have saved us a load of hassle.
Yeah, agreed.
In a new build, you could do things according to standard detail, so you could maybe avoid it. But in retrofit, you can't. So you have to go and do those calculations. And that was the big tricky in terms of certifying. My other comment would be I would get your certifier to come onto site rather than try and be completely remote. I'd get them involved. That's the difficult part, is the certifier, because you don't have a lot of budget for that, and you need people to come to site. So that's the tricky bit. That's probably about it. My major reflections.
Thank you, David.
Oh, sorry. Last thing would be, we went for radiators controversially as opposed to underfloor heating. And every heating engineer comes and goes, why don't you do underfloor? And you're like, well, I'm right on the edge of needing a heating system at all, right? And if we had gone down the energy demand route and had a bit more insulation on the floor and gone for PIR on the EWI, we could probably have done it on the energy demand method and been entirely on air rather than having a wet heating system. But it's fantastically easy and simple doing a wet heating system with radiators. And they're quite small radiators, right? Really small. So that was very easy. But all of these options are valid. Make your own choice, really.
Thank you, David. It's very useful.
So I'm not sure if you want to just go down
I've got
those
some
questions, Colin. I'll let you have a
Kevin,
read of
question
those.
from Kerry. What investigations were done to the property before you started thermal improvement design work? Well, the answer is there weren't really any investigations to do. We did the survey and we could see what the structure was and we could see the problems. But we didn't, for example, do an air test because that would have been completely useless. But there's a lot of debate in the Passive House community of doing air tests before you start a project to get your base reading. But frankly, why? It's just.
I mean, it was interesting when you first opened up and looked in the flat roof section in the middle of the house, and then you could see daylight out through the soffit vents of the flat roof. You're like, okay, so there is zero insulation here, and there is zero airtightness here. Okay, there's a good meter squared worth of open air opening. So, but at the same time, because it had been, you've got these big concrete beams, concrete lintels across above the windows on, almost the entire perimeter of the building. Then above the existing, and it had been double glazed and it's a concrete slab. So the bedrooms are actually quite airtight. So had then on the thermal bridge had black mold um, in the bedroom corners, and you could smell when, because it hadn't been lived in for a while, the building was actually quite musty. So you knew you had um, a thermal bridging problem there with those big concrete beams, and that covering those was going to be a big win in terms of having a continuous insulation, um, and that would sort out a lot of your problems. So you could fairly easily read the building, I think, if you had spent a while sort of thinking about building physics in the past. It's one of the attractions of it, actually.
I mean, we did what we could to avoid it, to close out as many thermal bridges as possible. For example, over the front door. I mean, that concrete beam is well wrapped, but in other places, like at the party wall,
Yeah.
the party wall is vulnerable.
Mm.
And the neighbors insisted on being able to, if sometime in the future, to build on top of their party wall, which is highly unlikely. So we had to change this detail to make it possible for them to remove a bit of insulation and build another wall on top. Never happened. I don't think it's going to happen.
No. No, not for something 20 years. Something like that. At least.
Okay, here's an anonymous attendee who asks, how did the client find you as the architect, project manager? Well, David, I mean, you could answer that, I suppose.
Yeah, so finding we talked to, I think, 3 architects in detail who visited site. And people from bigger firms were, very confident, tended to want to talk down to you, tended to say, well, you need much more money than you have. And it's a bit like, okay, we're in London, sure, but I'm not in banking. I don't have that much money, right? So, the budget, the project has to fit to the money there is. You can't just expand the project to
Exactly.
a building that I then have to sell afterwards because I can't afford to live in it. Um, and they were quite resistant to that concept. So, but we found Colin by searching the Passivhaus database of architects, basically, and then looking for people who are local. Local as in within our quadrant of London, I would say. So that's a sort of addressable market of like 3-4 million people. So if you're in Cornwall or something, that would be the whole of Cornwall and Somerset.
And from my point of view, the project was absolutely ideal being around the corner from me, because I'm actually semi-retired, but I'm really deeply interested in Passivhaus, and my mission is to do at least one a year if I can. And David's project was the most wonderful project to work on, and really fantastic clients. Can't say more.
Yeah, I mean, the nice thing is, I mean, we had a collaboration where we were doing things where both Colin and I were both, deciding things together, and that I think is vital through to having harmony together through the process. Yeah.
Any more questions? Surely somebody's got a question.
I'm not sure whether any of those that you've answered in the chat, whether you want to just expand on any of them, Colin, just in case everyone can't see the
Let's see, Mike. Okay, Mike asked a question about our bugbear, David, which is the failure of the U value of the flat roof windows. And I've fiddled the PHPP to get the U value of the frame down to what we need, but Mike Webb suggested a fixed double glazed or triple glazed window. Let me share my screen. Just bear with. This window here. So what we could consider doing is This is black for the time being to show what we talk about, but putting in a new window somewhere over here.
Mm-hmm.
And then we don't have to fiddle. It's a possibility.
Yeah. Okay,
Yeah.
I see the point.
Yeah.
Yeah. Yeah.
Okay, Sabine asked, Fab Project, did I do the Wi-Fi analysis yourself? No, I used the Passivhaus Institute booklet.
Yeah.
And Sarah Shuttleworth asked about the roof section. Everything was glued, basically.
Yeah.
And I don't think that, again, in terms of risk management, there's very little risk of the roof blowing off because it's held down by quite a few solar panels and air source heat pump and other bits and pieces. Gary Kelly asked the question which we answered, did we undertake a blower door test? And we said, no, not worth it.
Beforehand, no. But we did, I mean, obviously we did afterwards.
Yeah, no, we did at one stage. And I mean, I've got loads of pictures of wandering around site with a smoke device, finding which way the wind was blowing. And we found all the leaks and we fixed them. But you have to do the initial air test when you're reasonably sure that you've got most bases covered.
Yeah, the big one was the first air test. We didn't block up, or they didn't block the person doing the test didn't block up the MVHR's vents.
Yeah.
And that's
I spoke to somebody about that, and they said schoolboy error.
Yeah. And that was probably what took it from 0.8 to 0.6. Right. I don't know. Whatever it was.
Okay, we've still got some open questions. Kerry says, what investigations were done to the property before you started thermal improvement design works? Well, as I said, we didn't do any investigations. Mike says, this is a $1 million question, David. Will the scheme ever be certified?
Well, that is a $1 million question, isn't it?
That's a $1 million question, and it's something which David and I are discussing. Because
if it's just the, I think the solution for the two roof lights at the moment before today, the suggestion actually from the certifier from Thomas was to insulate around the perimeter of the frame, so it's just where the bottom of the frame is. So aerogel face with MGO board and then paint that, blend it into the. You could do that with sort of 20 millimeters or so insulation would probably do it. I need to go and do the Wi-Fi model, and then we'll be off. And it's a lot easier than modeling welding. Let's put it that way. I just need to get into Wi-Fi and do it. I need a few afternoons.
But the other issue is to achieve certification is it's a bit of a minefield because they insist on everything being exactly as it is laid out in the Passivhaus guidebook. So your photographs, for example, I didn't take photographs of the CE marks of the bundles of insulation that were delivered to site. Now we know what the insulation was. You can see it in the photographs. And because I don't have that photograph of the CE mark, our assessor is saying, well, sorry, you don't comply. Something like that should be really attended to for an EnerPHit. Okay, an anonymous attendee says, do you have any suggestions for clients who are not as technically minded? Well, yes, find a good professional who can guide you on the path, and leave the technical stuff to them, and they will try and include your requirements in with the technical stuff. You don't have to know all the technical stuff. I mean, I was really lucky that David is a boffin, and he was unwrapping the PHPP to find out what was the underlying algorithm that was driving the whole thing.
Unlock that sheet and find out, drag through and find out how that is calculating that and what exactly that number is and so on. Because there are some bits that are a little bit black around, especially around the way the windows are defined in PHPP.
Okay.
But
Another
there's
question from
the big
James.
thing would
Sorry.
be, there were decisions like for external wall insulation, say, if you're going down that road of what do you use? Do you go down a wood fiber? Do you go down an XPS or an EPS? Do you go down a PIR, which are there's kind of an embodied carbon argument, and there's sort of a thing whereby um, it helps to be a technically minded client, but actually an architect can tell you I mean, the best technical answer is, use something that doesn't have a lot of embedded carbon that doesn't present a fire risk, which would be wood fiber. Um, and I think if I was doing it again, I would probably go, well, look, you're going to end up doing so much roof work that extending the eaves isn't a big deal. So just, suck it up, extend the eaves. But when we were designing it, I was worried about that. So that's why we ended up with, with thinking about, and I would have done it with PIR 140 mil, but actually, if you just said 200 millimeters of wood fiber would have been equivalent, and I'd have extended the eaves if I'd have known how much work we ended up doing on the roof. And architects did say that to me. So there's some things where being a boffin actually, cuts against you because you know too much, right? And then you get obsessed with something that,
Yes, sometimes you can't see the wood for the trees.
yeah,
There's
right.
another
So
question you have from Jane Clayton. Did you model the existing building in the PHPP at the start? The answer
yeah,
is, well, yes, we did, because you have to put in the base data in order to add the additional data. Greg's, but I mean, we didn't model it as a potential because it didn't have any of the right components. Greg
yeah.
says, question about the brick slips.
Mm.
Can you expand on this area? Did the slips require additional support? And the answer is no, they didn't, as far as I remember.
No, so they were from Jewson, as in the builders merchants, who got them from Ibstock, and the thing there is matching them. But these are full bricks that are cut down, right? And by Ibstock, and then stuck on by some guys who the external wall installation company found and contracted. And they are so easy to stick on. It is just like, mix up some pointing cement and then smear it on the back of them and stick them on. Um, and and then point them up with a little gun. So it took two blokes a day and a half, pretty much. There was a bit of fussing about access, um, scaffolding going up and down and up and down, and about working off of platforms. Um, but apart from that, they were good as gold, actually. This is in, hilariously, a conservation area conserving a bunch of 30 semis, and the conservation area cares a lot about the preservation of brick coins and so on, because they're 30 semis that are sort of half brick, half render. Um, and yeah, what I tend to say to people there is, look, actually, putting brick slips on is really easy. If you want to put some coins on it, take two guys a day, So for the sake of making people happy, it's not worth the candle to argue it.
Yeah.
The only thing is that if you're drilling holes to put in your downpipes and stuff for guttering, you've got to drill through the brick slip itself on, and then through 100 millimeters of insulation, then put your insulation broken fixing through that goes all the way through that. So they're a bit of a hassle to work with.
Any more questions? I'm kind of answering questions as I go through this. We've still got 5 open questions that we've spoken about. How about the builder? Did you find one with some Passivhaus experience to teach them along? Well, I mean, we're answering this live. The answer is that David had a builder which he'd already used and knew well, who knew what he wanted. And he had an excellent team of some of the best carpenters and builders that I've come across. And it didn't take them very long to understand the whole concept of airtightness and how to do things. But the thing about construction management is that it's a responsibility, and you do have to be on site literally every day, and sometimes twice a day. And you have to be able to take a text message from the site foreman that says, I'm running out of plasterboard screws. Can you please go past Screwfix and pick them up? And that's what I did.
Yeah.
So it works very well.
Yeah, so in London you tend to have crews who will, bring tools but then they'll take the tube every day. So they don't necessarily they're not it's a bit different to the rest of the country. They're not necessarily like, oh, I'll just pop out in a van to screw fix, because there's no van. Um,
Yeah,
so but and Alex, um uh
the builder.
the builder, I'd previously been referred to by when doing a retrofit, which wasn't a passive house retrofit, on a previous flat, who had done a load of Pavatex wood fiber insulation on the internal wall insulation on our previous flat. Back when he was a younger man, and uh, and so he and his crew sort of get it in that sense. But they were, obviously most of their trade isn't doing this sort of retrofit. So, but when you've got a good carpenter who's interested in having, one internal wall we pulled down, because the lead carpenter was so upset with it being out of true.
Well, it's falling over, David.
Yeah, it was about 30 millimeters out of vertical, top to bottom, over 2.5 meters,
Yeah.
And he was of the opinion that making that good to then hang a bunch of partition doors in, dividing the living room from the dining room, was so much hassle. It was easier and more satisfying just to knock it down and build a new wall.
Absolutely. And you can
Right.
build a new wall properly with plywood
Oh,
behind the plasterboard so you can screw anything into the wall when you
yeah.
want to.
So
I
it's
mean,
it's an absolutely awesome wall, but you have got contractors then who care about things
yeah,
being really true, you know.
absolutely. Laser levels all over the place. I mean, the anonymous attendee says, "Were you pleased with their work?" I think we were very pleased with their work, David. And
Yeah.
I tried to get Alex to work on the bonus project I mentioned at the end, which unfortunately now is not going ahead. So next one.
Oh, okay. The I mean, one thing was like the boxes for the windows. The windows are you sort of build ply boxes for the windows to sit in that project out beyond the original bricks of the
Mm,
original building, so that you're in the plane of the insulation. And and you pay people to do window installation to then about making it true and airtight and everything else. But once you've built the enclosure for them, the guys turning up to do the window installation have the easiest job in the world ever, and are quite
uh,
frankly taking money from old
absolutely.
rope.
It
And I would,
does.
if they'd have let me, if Rationale would have let me, I'd have probably actually had the main building crew install them.
Absolutely. I agree. I
You know.
agree.
If you've got a good crew, then yeah, lots of other second trades, and life is much easier.
Here's an interesting question, David. Gary Kelly says, "How did you achieve the 0% overheating? Opening windows for nighttime ventilation?" We didn't. No, it turned out that way in the PHPP. We didn't really do
Yeah.
anything.
So you've got quite a bit of tree shading. On the south elevation, which is the front door, which is
Yeah,
out the side of the building, um, Colin put quite a bit of overhang in, right, of that
yeah.
extended out of the flat roof.
That definitely on the south side. I wanted a big overhang there.
And that makes a big difference to the heat load on the front door and onto those two windows. Um, and also means you get to not get wet while you're getting keys out in the evening when it's
Yeah.
raining.
I mean,
Um,
you can see the context in this picture. It is surrounded
yeah,
by big trees.
and then on the west elevation, it's not actually wasn't in the original PHPP, but I wanted to have it because I knew the heat load was quite big on a summer evening. They
Yeah.
do have external blinds on the big sliding door. And
Yeah, they're not showing up in the pictures I took because that was a late delivery. But
yeah,
yes, both
that was late.
both the west windows had external shading.
And they are great. But they are on an automatic trigger, right? So they are triggered by the sun and deploy. Yeah, you can see them there on the big window, but not on the
Yeah,
sliding door. Yeah.
yeah,
Um and uh and they are because we don't have blinds as well on the inside, they are also the means by which you avoid getting sun in your eyes when you're having dinner. They help you in terms of not losing a load of space to curtains on the inside. So yeah, yeah.
We're running out of questions.
Yeah, I think
Suggestions for clients who are not as technically minded. Well, we've done that one, yeah. And Mike, yeah.
Yeah, I think the questions have helped us to come in pretty much on time, actually.
Yeah. The last thing I'd say about the EWI there is on those pictures there is, we dug out the perimeter so that the EWI could go down into the ground, and then did the block paving at the end after all these photos were taken.
Yeah.
But that gives you a very warm feeling of confidence about how you've looked after your DPC and everything else. Having gone and done all of that external work, that's one of the big risks in retrofit is, are you looking after your DPC? And your void, if you have one, this doesn't have one.
Great.
Thank you. As it looks like there are no more questions, just for me to say thank you so much, Colin. And also, David, thank you for joining the session and answering some of the questions as a homeowner. I think that really helps, even though you are more experienced and knowledgeable, I'm sure, than the average homeowner with some of the technical detail. I think it really does help to bring both sides to the project to life. So thank you, everyone, for joining us today. Our next session is on Tuesday. All sessions are available to book on the Passivhaus website and on Eventbrite, and we will be following up with a copy of the slides and a copy of the recording of this. So thank you so much for your time, everyone, today yet again.
Thank you, Maeve.
Thanks a lot.
Thank you.